Hello and welcome to another tutorial. Today we are going to solve a question from the West African Senior Secondary School Certificate Examination, and it's from the year 2015. It's from question number 10. So we'll solve the 10A and after that we'll solve the 10B. The 10A reads, without using mathematical tables or calculators, simplify 2 tan 60 degrees plus cos 30 degrees all divided by 60. So that is the question that we are going to solve, and after that we go to the B. So let us see how we solve such a question. Now that is under a topic called trigonometry. Sine, cos, and tan are called trigonometric ratios. You know, their full names are sine, then we have cosine, and we have tangent. So these are called trigonometric ratios, and we take the sine, cos, or the tan of angles. For example, we can find the sine of an angle, say 30 degrees. We can find the cos of, say, 60 degrees. We can find say the tan of say 90 degrees. So these are all called trigonometric ratios. So basically we have sine, cosine, and tangent as the 3 trigonometric ratios. Alright, so now let us look at the question that we have to solve here. Now the first thing I want to say here is that if you look at the question, we see the angles 30 and 60. So first I want us to look at the trigonometric ratio of some basic angles, some acute angles. So I'm going to draw a table here so that we look at what I'm talking about here. Now let us that is the angle theta, and then I have here sine, so we have sine theta degrees, so sine here, and then I have cos also here, and the last one is tan. Now I'm going to look at some basic angles here, and I'm going to look at the angle 0, angle 30, I go to 45 degrees, then 60 degrees, then the last one will be 90 degrees. Normally I do not memorize these angles or the trigonometric ratios of these angles. I just use this simple method to remind myself in an examination if I happen to forget these angles. So what I'm going to do is that first I remind myself that the sine of 0 degrees is 0, but sine 90 is 1. So these are the two things that I always remember. That's sine 0 is 0 and sine 90 is 1. But before we proceed from here, I want to say something very small about the sine and cos. Let us look at something about sine and cos, sine and the cosine. Now one thing about these two trigonometric ratios is that there is something that we call complementary angles. When we say complementary angles, complementary angles are angles that sum up to 90 degrees. For example, if I take the angle 30 and the angle 60 degrees, these two angles are complementary. They are complementary because they sum up to the angle 90 degrees. Now in the same vein, if I take the angle 20 degrees and I take the angle 70 degrees, these are complementary angles. They are complementary because of course they sum up to 90 degrees here. Now the sine and cos, you know, have a very special relation when it comes to complementary angles. By this I mean, if you take the sine of any angle, say theta degrees, that is equal to taking the cos of 90 minus theta degrees. So if I have to give an example here, then what I'm trying to say here is that, for example, if I say sine 30 degrees, this will be equal to writing cos 90 minus 30 degrees. That is sine 30 degrees here is of course equal to cos 60 degrees, because when you subtract 30 from 90 here, you have 60 degrees. So let us try to look at some few examples before we continue from here. If I write sine 10 degrees, then this is equal to cos 80 degrees. It is so because 80 plus 10 gives 90 here. So these two angles are complementary. That is the relation between the sine and the cos. Now let me give some few more examples. Sine 20 degrees will be equal to cos 70 degrees, because 70 plus 20 is equal to 90. Sine 45 degrees will be equal to cos 45 degrees, because 45 plus 45 gives 90 degrees. So what do you think will be equal to sine 0 degrees in terms of cos? Of course, I'm sure you have guessed it right, and that is cos 90 degrees, because 0 plus 90 gives 90 here. So that is a very simple relation between the sine and the cos. So we are going to use this simple relation to remind ourselves of these things, and we're going to use this to solve these questions. Alright, so now let us go on with what I'm saying here. I have said that the first two angles, or sine of the two angles you have to remember, is sine 0 and sine 90. So right from here, I can also find, the sine. I can find a cos of 0. Now sine 0 degrees, let me put it here. We have found sine 0 degrees, but sine 0 degrees is the same as cos 90 degrees, because 0 and 90 add up to 90 degrees. So sine 0 degrees is 0. So cos 90 degrees here too, here is also going to be 0 here. Alright. And I also know sine 90 degrees, and I know sine 90 degrees. Sine 90 degrees is 1, and sine 90 is equal to cos 0 degrees. So cos 0 to here has to be 1. Now, I know sine 0, sine 90, cos 0, and cos 90. Now the rest here have to be this way. Now, sine 30, 45, and 60, and then of course 30, 45, and 60 are also remembered using this very simple approach. Now you write a division sign here, and you divide it by 2. So something here divided by 2, something up here divided by 2, something up here divided by 2. Now the next thing you do is to write 1, 2, 3 here. So 1 over 2, 2 over 2, 3 over 2 is very simple. So 1, 2, 3 all divided by 2. But I'm not done yet. And the numerator, you take square roots of the numerators. So the roots of 1 over 2, the root of 2 over 2, and the root of 3 over 2. Now I can go on to simplify the root of 1. Now the root of 1 is 1. So with this I can take off the root sign here, so that I'll have only 1 here, because the root of 1 is 1. So I'm gonna have this, and that will be very simple. Now, so that is that. And how do I find the cos of these angles? I think you have guessed it right, because sine and cos are involved in this complementary angle stuff. Cos 30 will be the same as sine 60 degrees. Cos 30 is equal to sine 60. Sine 60 is root 3 over 2. So cos 30 will also be root 3 over 2 here. and cos 45 is the same as sine 45, because 45 plus 45 gives 90 degrees. So here too we will have the same thing, root 2 out of 2, and cos 60 will be sine 30. Sine 30 is half, so cos 62 is going to be half. So these are pretty simple. So these are the sine cos of these, acute angles up to the right angle 90 degrees. Now let's come to the tan. The tan can be expressed in terms of the sine and the cos. There is a very nice relation between the tan and that of the sine and cos, and that is what we are going to explore. Now, when I write tan of an angle, say tan theta degrees, this can be expressed as sine theta degrees divided by cos theta degrees. So what I'm trying to say here is that the tan can be expressed in terms of the sine and cos. So let us start from here. If I want to find tan 0 degrees, I can express this as sine 0 degrees divided by cos 0 degrees. But I also know sine 0 degrees. From here, sine 0 degrees is 0, so that's going to be 0, divided by cos 0 is 1, so here is going to be 1. And 0 divided by 1 is 0. So that means I'm going to have 0 here. Alright, let's go to tan 30 degrees. Now, tan 30 degrees can also be expressed as sine 30 degrees divided by cos 30 degrees. And sine 30 degrees is half. So half divided by cos 30 degrees, and that is root 3 out of 2. Now let me write this well. That is like this: half divided by root 3 out of 2. So I can change the division sign to multiplication, so that I'll have half times 2 out of root 3. And from here, 2 will go into itself 1, 2 here 1, and I'll have the final answer to be 1 out of root 3. I can even go on to rationalize this by multiplying the numerator and the denominator by root 3, and I'll have root 3 out of 3. So tan 30 degrees is root 3 out of 3. Now let us go to tan 45 degrees. Tan 45 degrees to tan 45 degrees can be expressed as sine 45 degrees divided by cos 45 degrees. Now sine 45 degrees is root 2 out of 2, and so root 2 out of 2 divided by, and cos 45 degrees is the same root 2 out of 2, and that is equal to writing root 2 out of 2. Then I can change the division sign to multiplication, and when I do that, the term here, the numerator and the denominator will interchange, and I'm going to have 2 out of root 2. So let me do some simplification here. 2 here 1, 2 here 1, root 2 here 1, root 2 here 1. So I have 1 times 1, that is 1, and 1 out of 1 is 1, and 1 out of 1 is 1. So I'm going to have 1 over here. So that is tan of 45 is 1. Okay, now let me go to tan 60 degrees. Tan 60 degrees can also be expressed as sine 60 degrees divided by cos 60 degrees. Sine 60 degrees is root 3 out of 2 divided by cos 60 degrees, and cos 60 degrees to is half. So I can change the division sign to multiplication, and I'm going to have 2 out of 1 here. Okay, so let me simplify this. 2 here, 1, 2 here, 1, and I have root 3 times 1. I have root 3, and 1 times 1 is 1, so I'm going to have root 3 as the final answer here. So tan 60 degrees is root 3. Now we are left with the last one, that is tan 90 degrees, and let me put it here. Tan 90 degrees is going to be sine 90 divided by cos 90. Sine 90 is 1, cos 90 is 0. And we cannot divide by 0. It's like saying 0 people share 1. I mean, how can we have 0 people? We cannot. 0 is not a counting number, so this expression here is undefined. So we're gonna put a sign like this over here. It's undefined. It doesn't make sense here. So these are the trigonometric ratios of these acute angles up to the right angle 90. So sine 30 half, sine 45 that, and we can use this to solve the question that we've been asked to solve. Anyway, the question features the angles 30 and 60 degrees, so it's going to be pretty simple here. And you can remind yourself of these angles, the trigonometric ratio of these angles, because it's pretty simple. Sine 30 is half, and if you know sine 30, then you have to know cos 60 degrees, because 30 and 60 are complementary angles, the angles that add up to 90 degrees. All right, so back to the question, and we solve it here. So we have 2 tan 60 degrees plus cos 30 degrees. Let me write it here. 2 tan 60 degrees plus cos 30 degrees divided by sine 60 degrees. Okay, and we continue. We have 2 here, and tan 60 degrees is root 3, so tan 60 degrees is root 3. So we have 2 root 3 plus cos 30 degrees. Cos 30 degrees is root 3 out of 2. So we have root 3 out of 2. So we have all divided by sine 60 degrees, and sine 60 degrees 2 is root 3 out of 2. So we have root 3 out of 2 here. Okay, so we have the numerator and we have the denominator. Now, one thing you have to see here is that 2 root 3 is the same as 2 root 3 out of 1 here. And because we have a fraction here that is root 3 out of 2, I want us to first simplify the numerator. So we have 2 root 3 plus root 3 out of 2 here. So that is the numerator. So let me put this in square brackets so that we look at this very well. So divided by, then we have root 3 out of 2 here, and that is going to be root 3 out of 2. And from here we can find the LCM here. We have 2 root 3, and that is the same as 2 root 3 out of 1. And the LCM here, 1 and 2 is 2. Now 1 goes into 2, and 2 times 2 root 3, that is going to be 4 root 3. Okay, so we have 4 root 3 plus 2 goes into 2, 1 times root 3, we have root 3 here. So that is that for the numerator, divided by root 3 out of 2. Now let us go on to simplify what we have up here, and let us try to look at this very well here. Most students have problems simplifying sets, and that is the reason why that I want us to look at this before we go on here. Now if you have something like 4 root 3 plus root 3, now there is a number in front of this third, and that is the number 1. There is a coefficient of the root 3. You know, sets can be thought of as variables. For example, if you have something like 4x plus x, you are obviously going to say 5x, because x here is 1x, and because they are like terms, you can just add them, or in other words, you can bring out the x, factorize out the common term, that is the x here, and you'll be left with 4 and 1 here. So 4 plus 1, and of course you have x and 5, so you have x times 5 here, and the final answer 5 times x, or x times 5 is 5x. So in the same vein, that is how you solve sets. So anytime that you have like terms, you know, we have root 3 here and we have root 3 here. So what you have to do is to factorize out the common term. So I'm going to bring out the root 3 here, so that in the brackets I'll be left with 4 plus, and I'll have 1 here. So I have root 3, and when I add 4 to 1, I get 5. So I have 5 here, and root 3 times 5, that should be 5 root 3. So when you multiply a rational number by the third, we write the rational number first, that is the 5, then we add the third, or the irrational number. So what I'm saying here is that 4 root 3 plus root 3 is going to be 5 root 3, all divided by 2, and we have divided by root 3 out of 2 here. So we can change the division sign to multiplication, so that the term on the right will be altered a bit. So we have 5 root 3 out of 2, then we have times, and the term here, the numerator and the denominator will interchange, so we are going to have 2 out of root 3 instead of root 3 out of 2. So 2 here 1, 2 here 1, and root 3 will cancel root 3. So what will be left here is 5. So the final answer to this question is 5. If you doubt yourself and you have a calculator, you can verify it and see. Now let us use a calculator to verify our answer. You first press on the fraction template, then you type 2 tan 60 degrees plus cos 30 degrees divided by sine 60 degrees. And you have 5 as your answer, so that is correct. Now we look at the B. The B reads that from an aeroplane in the air and at a horizontal distance of 1050 meters, the angles of depression of the top and base of a control tower at an instant are 36 degrees and 41 degrees respectively. Calculate, correct to the nearest meter, their I, height of the control tower, II, shortest distance between the aeroplane and the base of the control tower. Now, when we talk about the angle of depression, let us try to understand what we mean by angle of depression. So I'm going to draw something very simple here to represent my plane. I'm not too good at drawing, so let us take this as an aeroplane here, and let me put the control tower here. So let me draw something here to represent the control tower. So that is the control tower, and that is the ground floor. So my floor is a bit okay. Let me draw a nice floor here. All right, that is better. So that is the top of the control tower, and here is the bottom of the control tower. Now, from this aeroplane, let us look at the question again. It says that from an aeroplane in the air, so the aeroplane is in the air and at a horizontal distance of 1050 meters. So the aeroplane is at a horizontal distance of 1050 meters from the tower. So let me indicate this here. So what we're saying here is that we have 1050 meters here, and that is in between the aeroplane and the tower. That's what we can see here, and it's a horizontal distance. Or you can think of it to be somewhere here. It's the same thing, that is from here. So it's a horizontal distance from the aeroplane to the tower is 1050 meters. So that is the distance here. So that's what the question says. Now, when we talk about the angle of depression, the angle of depression is the angle between the horizontal eye level, and the angle of depression from an object is the angle between the horizontal eye level and that object. For example, if we have the aeroplane and here, and there is an object here, and I want to find the angle of depression, or if I say that the angle of depression from the aeroplane to this object, if I say the angle of depression from the aeroplane to this object is say 30 degrees, what it means is that first I have to draw my horizontal eye level from the aeroplane. So there is a horizontal eye level here. So there is the eye level and it is horizontal. So from the from the horizontal eye level, the point where you have to lower your eyes to see the objects between that horizontal eye level to the point that you have to lower your eye to see the objects between these two lines is what we call the angle of depression. You depress your level of sight, so you bring it down from the horizontal eye level here. So we have two angles here. We have the angle of elevation, which you talk about in other questions. That is, as the the term suggests, to elevate is to lift. So the angle of elevation is between the eye level, that is the horizontal eye level, and the point where you raise your eye to look at the objects up there. So talking about the angle of depression, of course, that is also the angle between the horizontal eye level and the objects that you look at it. So that is what we mean by angle of depression. So now let us look at the question again so that we draw or we complete our diagram. So it says that from the aeroplane in the air and at a horizontal distance of 1050 meters, the angles of depression of the top of the base of the top and the base of the control tower. So this means from the aeroplane we are looking at two things here. The first thing is that we are looking at the top of the tower, that is here. Then we are also looking at the bottom of the tower. So from the aeroplane, looking at the top of the tower and that of the bottom, we have 36 degrees and 41 degrees respectively. So respectively means that the first for the first one and the second for the second one. So that means that if you lower your eye from the points, that is from the horizontal eye level, to look at the top of the tower, the angle that you go through is 36 degrees. So from the aeroplane to the top of the tower, you go through an angle of 36 degrees before you can see the top of the tower. So here is 36 degrees. Now it also goes on to say that, and if you want to see the bottom of the tower, then you have to lower it further, so that you lower it at an angle of 41 degrees. So let me draw a very nice straight line. My lines are a bit crooked. All right. I'm going to draw a solid line here. I think this will be, oh my god, this is not good. Oh, all right. Okay, this looks a little better. Let me try to I'm finding it difficult to draw a straight line, but I think I'll make do with this. Okay, not bad. And let me also draw a solid line here instead of dotted lines. Yeah, not too bad, not too good anyway. So now this angle that is from the horizontal eye level to the bottom to makes an angle of 41 degrees. So you can see that here an angle of 5 degrees is here, because 5 plus 36 gives you the 41. Okay, so we have two angles here. If you lower your eye from the horizontal eye level to the top of the tower, you cover an angle of 36 degrees, but from the horizontal eye level to the bottom of the tower, you cover an angle of 41 degrees. So what we're gonna do here is that the question says we are to calculate correct to the nearest meter the heights of the control tower. So where is the height of the control tower? Now that is the control tower. So from the bottom here to the top is the height of the control tower. So let me label this as small h. I'm calling the height of the control tower small h. So we are going to find small h here. Now normally when you're solving a question in maths, what I do tell my students is that before you even begin to solve it, you have to ask yourself, what values, or what variables do you know? What has been given to you, and what have you been asked to find? Now if you look at the question very well, you see that you have been given three things. Now the first thing is that you've been given the horizontal distance between the aeroplane in the air and that of the control tower. Now the second thing is that you've been given two angles. First, you've been given an angle 36 degrees, that is the angle of depression to the top of the tower. That is when you lower your eye from the horizontal eye level to the top of the tower, the angle you go through is 36 degrees. And when you lower your eye from the horizontal eye level to the bottom of the tower, the angle that you go through is 41 degrees. So finding the height here, you have to deal with plane geometry, or you deal with some plane figures, and chief among them is a triangle. Now let us try to look at this shape very well. Now if I draw a solid line here, you see that this line here and the horizontal eye level, they make an angle of 90 degrees, because there is vertical and there is a horizontal line. So when they meet, they make an angle of 90 degrees here. Now because I know the angle 36 degrees, and let me label the triangle so that we look at what is actually happening here. I'll also draw a solid line here so that it becomes a bit clearer. So let me put some points to label these points that we have. So let me call here A, and I'll call here B. Let me label here C. Okay, or maybe all right, it's okay. So we have A, B, C, and let me put D down here. So we have the line AD, and we have AB and BC, and CD. Yes. Now, so what we say here is that we have to find this height, and to find this height, what angle do we know here? The small angle here is 5 degrees, but we cannot use this. But we can have a look at this right angle triangle, because it's pretty easier to use this right angle triangle, that is ABC, because we can employ Pythagoras theorem that deals with sides, and of course we can also use trigonometry, that is the sine, cos, tan. And if I'm going to find the height here, that is the small h here, the angle that actually covers up to this point is the angle 41 degrees. So I'm going to consider the right angle triangle ABD. I'm going to consider the right angle triangle ABD. So let's do it this way. There is a right angle triangle, and the side BD, the side from B to D of the right angle triangle faces the angle 41 degrees. In other words, this side is opposite to the 41 degrees. So the side BD, the length BD, so let me see, length BD is opposite to the 41 degrees. And of course, the length AB to AB is adjacent. Length AB is adjacent to the 41 degrees. Now I'm using the angle 41 degrees because that is the angle that covers up to the height I want. The small height is DC, but it is part of the bigger let me say line or height or length BD here. All right, and let me give a variable, or let me label this height that is from B to C. I'm going to call it the length, let me call it the length X here. Okay, small x here. So if I want to find an expression in terms of h, of course if I want to find h, then I have to develop an expression in terms of h. So how do I connect h to this right angle triangle that I have here? That is the right angle triangle ABD. All right, this is how I'm going to do it. So I'm going to write tan of the angle 41 degrees. And there is something I want to remind you of in trigonometry. There is something that we use to remind ourselves of these trigonometric ratios, how they relate to the size of a right angle triangle. There is something that we call SOHCAHTOA. So we call it SOHCAHTOA. And what this thing means is the S here stands for sine. So it means that if you take the sine of any angle, you can express it as being equal to the opposite side. For example, if let me explain this a little bit here before we go on from here. Sine, cos, tan, the SOHCAHTOA I am talking about here deals with the right angle triangle. So I'm going to draw a right angle triangle. This one will be an upright one. It's not going to be inverted like like the one that we see here, but it should make a bit of sense here. Okay, I think I will put it this way so that it will make simple or equal understanding. I'm not good at drawing these lines. I think I have to improve on drawing lines. All right, this one is gonna be good, trust me. Okay, all right, I will make do with this. Okay, so the angle 90 is here, and let me label these points. Let me call here A, B, and I'll call it D, like the first one. Now if I put any angle here, first this side, that is the side AD, is called hypotenuse. We call it hypotenuse. And there are two things to bear in mind when you talk about the hypotenuse. The first thing is that the hypotenuse is the longest side. First, it is the longest side of the three sides. And the second, and to me the most important, is that it is the side always opposite. It's always opposite to the 90 degrees angle. So from this right angle triangle, you can see that this side directly faces the 90 degrees angle. So even when in a question they draw a right angle triangle, something like this. You have a right angle triangle like this, and you see something like that over here. That is 90 degrees here, and here is A, B, C. In the axis of the hypotenuse, don't be confused, because normally you see something like not drawn to scale. Not drawn to scale means that, of course, they didn't measure the sides or lines. So what you have to do is to pay attention. You don't have to say that AB is the longest side here, so that is the hypotenuse. No, the most important thing is that what faces this 90 degrees angle, and what faces it is the side BC. So BC in this case is the hypotenuse. So I'm talking about the hypotenuse. It is the longest side, of course, and also the most important thing you have to note here is that it is side opposite to the 90 degrees angle here. So when you talk about right angle triangle, the longest side and the side opposite to the 90 degrees angle is what we call the hypotenuse. Now, after talking about the hypotenuse, you are left with two other sides, okay? And these two sides alternate in terms of where the angle is. One is called the opposite side and one is called the adjacent side. So if I put the angle somewhere here, if I put the angle here, say theta degrees, now this angle here faces the side BD. So in this case, it makes the side BD the opposite side. So we don't just say opposite. Opposite to what? Opposite to the angle theta degrees. So that will make the side AB automatically an adjacent side. So if BD is the opposite side, then the length so the length AB becomes the adjacent side. All right, so what you see here, the A is for the word adjacent, H is hypotenuse, and O is opposite, A is adjacent. So the first letters that you see here stand for the trigonometric ratios, that is sine, and the second one here is cos, and the third one here is tan. So this means the sine can be expressed as the opposite side divided by the hypotenuse, and cos 2 can be expressed as the adjacent side divided by the hypotenuse, and the tangent or the tan of the angle can also be expressed as the opposite side divided by the adjacent side. So now let us come back to these and find the sine, cos, tan of these angles, and after that we go back to solve our question. Now, example, if I write tan theta degrees, find tan theta degrees. Now there is theta and tan is twa, that is opposite over adjacent. So first you ask yourself, which is the opposite side? Of course, BD is the opposite side, so the length BD divided by the adjacent side, and that is the length AB, so divided by AB here. So that is how we can express tan theta. And if you ask to find sine theta, and I think by now you get me right here, sine is opposite over hypotenuse, that is so the opposite side is the length BD, and hypotenuse side is the longest side, and that is the side AD. Okay, so sine theta can be expressed as BD over AD. Now let us look at the last one here, cos theta. Cos theta degrees to cos is ka, so we see ka as adjacent over hypotenuse. So with respect to the angle theta degrees, the adjacent side is AB. So we have the length AB divided by the hypotenuse side, and of course that is the length AD. So we have AD here. Now what if we have the angle here? So let's put the angle beta degrees here. Now we have expressed theta. We have found the sine cos tan of theta degrees. Let us look at the beta. So if we are asked to find, say, tan beta degrees, now to beta, to the angle beta, the side that faces it is the length of the side AB. So to the angle beta, the opposite side is AB. So tan is opposite over adjacent. So the opposite side to the angle beta is the length AB. So please take note here. You know, for the theta, the opposite side was BD. And for the beta, the opposite side is AB, because of course AB faces the beta here. So opposite side of adjacent, and adjacent side will be the length BD. So the opposite and the adjacents have interchange, and that is what I said exactly. The sides that are labeled as opposites and adjacent depend on the orientation of the angle. That is where we have the angle. All right. So when I find, we go to the next one, and that is sine of the angle beta. So if we find sine beta degrees, and sine is opposite, so to beta the opposite side is the side AB, and hypotenuse does not change, so that is going to be the same AD. All right, and we take the last one, that is cos. So we say cos beta degrees here is going to be adjacent over hypotenuse, and to the beta, the adjacent side is the BD. It doesn't face the beta, so that is the adjacent side. So it's going to be the length of the side BD divided by the hypotenuse, and that is still the side AD. So that is the way that we express sine cos tan of these angles, and that is exactly what we have to use to solve our question here. All right, it has been a very long way here, but I think we will get the hang of it. And let me go back to solve the question. So what I'm gonna do here is that, you know, we have two right angle triangles here. We have the right angle triangle ABC and the right angle triangle ABD. So now what I'm doing is I am considering the right angle, that is the bigger right angle triangle, and that is the right angle triangle ABD. Now ABD, that is tan 45 degrees, can be expressed as, no, I am saying tan 45. I'm using tan because I know the side AB. The side AB is 1050 meters or 1050, and of course to the angle 41 degrees, the side AB is adjacent to it, and the side B to D is opposite to the angle 45 degrees. 41 degrees. I am not using AD because I don't know AD, and of course I don't want to find AD at this level. So tan 45 degrees is the side BD divided by, so opposite of adjacent, and the side AB. Okay, now let me go on this way. BD is from here B to D, and that is x plus h, because we have x here. So x plus h, the whole of x plus h forms BD, and then I have AB. AB is 1050. So I have tan 41 degrees equal to this. All right, remember that I'm finding h, but to find h, of course, I have to know s, because finding h means that I have to make h the subject, and then I cannot find h when I have two variables yet one equation. If I have two variables, then of course I have to get two equations so that I can express one in terms of the other. I can make h the subject or express h in terms of s, and of course by doing so I can find h. So let me try to see if I can find another equation here, and of course I can find one, because remember I was given two angles of depression. The first one I've used, that is 41 degrees, and the second one is 36 degrees. Now 36 degrees is the angle in the smaller right angle triangle. That is the right angle triangle ABC. So why don't I draw these things down so that you have a better look at them. That is the small right angle triangle. Okay, and there is 90 here, and you see the ABC here. Okay, and then the side here is x centimeters or x, so from here to there is x, and then of course here from A to B is 1050. all right, and the angle here to is 36. So that is the small right angle triangle. Let me add the bigger one so that you can make the comparison here. So this was the bigger one. I'm making it bigger so that you see it well. Okay, yeah. All right, so here too we had A, B, and remember that here was D, and right angle triangle. So here is the 90 degrees angle, and the length AB. You know, we have AB here, so the same thing. You have 1050 here, and then from B to D is going to be x plus h. Okay, so and the angle that we have here is 41 degrees. All right. Okay, so when you compare these two right angle triangles, what do you see? What is the common side that you see? Now here we have AC, but here we have AD. Here we have BC, here we have BD, but we have AB and AB. So we have one side that is common to both. All right. Now let me go on from here. Let me consider the small right angle triangle. And here I know 1050. I know this angle 36 degrees. The side AB that I know that is 1050 to this angle 36 degrees. This side is the adjacent side. Now I want to find x, and to the angle 36, x is the opposite side. So opposite and adjacent sides, then I have to use tan, that is toa, sokatua, right? So I write tan 36 degrees and I express it as the opposite side, and the opposite to the angle 36, that is the side facing 36, is the side BC, and the adjacent side to this is the side AB. All right, so 36 degrees tan 36 degrees is going to be the side BC, and the side BC is 1050 divided by the side A. Oh, sorry. BC is the side X. The side BC is the length X meters. So it is X meters. It's gonna be X here. Okay, so I have X, and the side AB is rather the 1050. Okay, so I have this. And if I'm going to find x, then I have to make x the subject. So simple cross multiplication here, and you get what I mean. So 1 times x, then we have tan 36 times 1050. So we have x to be equal to 1050 tan 36. All right. So let's see how this can be solved. Let me pull on my calculator and I'll type tan 1050 tan 36 degrees. All right, and I see 762.869. so all right, 762.87 is okay, and that is the length of BC, or that is x. All right, so from here, now that I know x, I can find h. So let me go back to this equation, the equation 1. Let me call this equation 1, and let me call this equation 2. So I'm going back to equation 1 here, and I'm going to make h the subjects, Alright, so I have tan 41 degrees. Why do I keep saying 45? Alright, tan 41 degrees equals x plus h, that is from equation 1, divided by 1050. So this is the same as over 1 or out of 1. And let me do cross multiplication here. So 1 times that, then I have tan 41 times 1050. And I have x plus h 1050 tan 41. Alright, so finding h, I make h the subjects, I leave the h here, 41, and then let me send the x to the right hand side. So h is equal to 1050 tan 41 minus x is 762.87. Okay, so h equals 1050 tan 41. Yeah, 41 here. And let me pull on my calculator. Alright, so let me check it from the calculator. 1050 tan 41 minus 762.87, and that gives 149.88. Alright, let me put it here, 149.88. So I have 149.88, and I am to leave this in the nearest whole number, so that is going to be 150 meters. So that will be the height of the tower. Alright, so the II also says we have to find II from here. We have to find the shortest distance between the aeroplane and the base of the control tower. So the shortest distance between the aeroplane here and the base of the control tower is the length A to D. So in other words, we have to calculate for the length AD, which is here, and we can find that in the bigger right angle triangle here. To find the hypotenuse, that is AD, I can use this side, or I can choose to use this side. And of course, I'm going to use the 1050. I don't even think I have to think about this side, because I just need two values here, that is an angle and a side. So what I'm going to do is, because I'm finding this side, which is the hypotenuse, that is h, and I want to use this side AB, which is adjacent to the angle, that is A. Of course, I'm going to use cos. If I had used 912.87, of course, that is opposite, I would have used sine. But because of the decimals, I'm going to use this exact value. I think that one is cool. So I'm going to write cos 41 degrees equals the adjacent side, which is the side AB, over the hypotenuse side, which is the side AD. Okay, so AB is 1050 meters, and then AD is not known, so let me put AD still there, and cos 41 too is here. So if I want to find AD, then I have to make AD the subjects. So to make AD the subjects, I'm going to have this. I will swap this. So I'll have the length AD to be equal to 1050 divided by cos 41 degrees. So let me get back to my calculator so that I evaluate 1050 divided by cos 41. So I have 1050 divided by cos 41, and I have 1391.26. 1391.26. So 1391.26 meters, and I'm to leave this to the nearest whole number, so that is going to be 1391 meters. Alright, so that is the answer to the II. We have 1391 meters. Thank you.